Good day, everyone. Today we'll be talking about the method of sections in structural analysis, and we have various methods of analyzing our trusses or our members. For instance, we can use method of sections, method of joint, and also graphical method. So in this case, we are going to adopt the three independent equilibrium equation, which are summation of forces along the x-axis, summation of forces along the y-axis, and summation of moment about particular point O to be equal to 0 in this method of section. So how do we go about it? Let's go to this particular example. Now, this is a truss. In this truss, we have a point load acting 1000 Newton downward, and it's having two supports. This one is a pin support, while this is a roller support. Now, how do we analyze this particular truss to know the tension or compression or compressive force along any of the members? So, for instance, this particular one, we want to determine this force here, and this one here, and this one here. So, how do we go about it? Using this method, we make a cut along where we want to make, want to determine the force. And after doing that, after making the cut, the first thing we're going to do is we must ensure we get the value, the forces, and let me say the reaction at each support. For instance, in this pin support, as you know, we will determine the forces along the S and Y component, while for this ruler, it's just for the, let me say, S component in this direction now. Now, let us go about it. After making the cut, we have something like this. Now, mind you, if we make a cut and in the cut, where we made the cut, the forces along this component, if it's pointing in this direction, then if we're looking at it from this other direction, it will be pointing in the other direction, just like our shear force too. Now, looking at this now, we first determine the force dx, dy, and es first. After doing that, then we'll be able to resolve this particular component. So what to determine this one, we can let me say we can take moment about this first. Let me say before cutting, we can neglect all these forces, taking it as a single member, then take moment about this place. We determine this force times this perpendicular distance minus this force times this perpendicular distance equals to 0. That will enable us to know what our value of ES is. After determining our ES, then we can say, okay, let's take moment about maybe this point. Then ds times is not going to have perpendicular distance, while ds will be determined. Then later we can resolve this ds. Definitely this ds is supposed to be, if you sum forces along the y component, ds and dy is likely to be 1000 Newton, because if you sum forces along the y-axis, there's no other force apart from this. So definitely this one is going to be, this is going to be the same with this, so that there can be balanced equation or equilibrium. Now, having done this, what we need to do next is this member that we are cutting. We'll look at, okay, we want to determine this, since we already know this reaction here and also this one. If we want to, the first thing is we look at this joint. This joint is having two members, so we can take moment about this point. Then that will help us to determine this force. To determine this force and this perpendicular distance minus this force times this perpendicular distance, then plus this force times this perpendicular distance, will enable us to know what our FGY is. If we know this, then we can also do the same thing for this particular case here. Taking moment about this point, we will know this force and this perpendicular distance is the same as this force times this particular distance. That will help us to know FBC and FGH has been determined now. So to get this FGC, we can resolve along the S or Y component to determine that. If we resolve this one along this component, we can say FGC sine 45 equals to 1000 Newton. So we can get FGC out, because if you look at this member, that's the only member, that's the only aspect that we can resolve along this component to get this particular force here. So having done that, that is all about this method of section. So you can put that into check, try and do the calculation manually and see what you get. So for this instance, okay, the calculation is not there, but just try that and let me see what you are going to get. Thank you.